This first presentation of mine today is about a trial that we finished a couple of years ago looking at an in-shed sprinkler system. Our interest in this was for reducing the humidity inside the chicken sheds and seeing how that affected litter management. But we'd also heard that it was good for saving water and for cooling birds, so we just wanted to have a bit of a investigation to see how well it stacked up. So before I get moving too far, I'd just like to acknowledge the people who supported the research. So that was AgriFutures Australia and the Queensland Department of Agriculture and Fisheries. And also like to thank the growers and integrators who allowed us to do the trials on their farms. So when I'm talking about in-shed sprinkler systems, we have to be clear that it's not talking about fogging. It's using low water pressure of about 40 to 50 psi and actually trying to get water to settle onto the birds in the shed. It's not like turning the tap straight on. A special controller is used to apply water for just a few seconds at a time, but at regular intervals, and the water evaporates off before the next lot goes on. You might ask why we were interested in this. Well, there was research that developed this sort of system and tested it in the US, and they found some really good results with bird performance, but with litter management and cooling of the birds as well. And since then, one of the major integrators in the US has also been encouraging farmers to install the system as well because of the benefits that they've seen with it. So the system that we installed had 2 rows of sprinklers running the full length of the shed, and it was split into 2 zones at the front and back of the shed. A controller was used with the system, and it had a temperature sensor in both the front and the rear zone of the shed. And what this allowed the sprinklers to do is to operate independently in the 2 different zones. So if it was hotter at the back of the shed, the sprinklers there could operate more often. In one of the sheds, we noticed that there wasn't great coverage of the water, and so we added a 3rd line of sprinklers in the middle of the shed. But since doing the trial, there are new sprinkler heads available that throw the water a bit further, so the 3rd line really isn't necessary anymore. This figure tries to show the program that we were using with the sprinklers. So we didn't use the sprinklers at all for the first 14 days. And then we turned on what was called activity promotion, which was purely a timer operated sprinkler application where 10 seconds of water was applied every hour during the day. After day 21, we then activated the cooling mode. And what that means is that if the air temperature in either zone of the shed got above the set level, which could be set by the grower, the sprinklers would operate for about 20 seconds every half an hour, and that frequency would increase if the air temperature continued to get warmer. By doing this, what we did was we pushed back the use of the cool pads. So the use of the cool pads was delayed to enable the sprinklers to take the lead of the cooling. But once the air temperature got about 4.5 to 5 degrees above the first set temperature, for cooling, then the evaporative cool pads would still be activated with the normal shed ventilation system. You might think that we're crazy trying to put extra water into the shed, but it's really small volumes of water. A 20-second application only adds about 25 to 35 litres of water throughout the entire shed floor, which is only about 15 millilitres of water per square metre. And what that means in real terms, if you have a look at the figures on the screen, the dark sort of shading on the drinker line, the auger line, and the feed auger line, the spots there, that's the water. So it doesn't even connect the dots effectively. And you can stand there and you watch that water evaporate off before the next lot is applied. And that's why the litter doesn't tend to get wetter. As far as results, the biggest result that we saw was water saving. So by pushing the cool pads back a little bit and delaying their use, the sheds use 27 to 77% less water, which was about 3,000 to 136,000 litres less water per shed per batch. and we saw the greatest savings during mildly warm weather before the cool pads were needed. As far as litter conditions go, well, we found that the litter was drier at one of the trial farms, but it was a little bit wetter at the other one. But it changed at different times of the batch, and there were no consistent trends. So I think it would be hard pressed to say that the sprinklers were responsible for either drier or wetter litter, given that there's all the other factors that affect litter conditions. When we're talking about activity promotion, I've got a short video here that shows what happens when the sprinklers turn on. So you can see all the birds sitting, just basically sitting down, fairly quiet. Sprinkler turns on, and once the water reaches the birds, you see most of them stand up. That releases the heat that might be trapped between them and the floor, and then many of the birds will go and have a drink or eat. At this time, the sprinklers are running about every 7 minutes. So it kind of shows that the birds do continue to stand up when the sprinklers are activated. The biggest difference between using sprinklers and the evaporative cool pads is that the cool pads cool all of the air coming into the shed, and what that does, you'll see in the figure on the left there, is that it cools most of the surfaces inside the shed. So the ceiling, the walls, everything is sort of cooled by the cool air coming through the cool pads. But within this shed with the sprinklers, the air temperature within the shed is much more like the ambient temperature, and the cooling effect is only really on the birds themselves. But the big difference is humidity. So in the shed with the cool pads running, the relative humidity was about 85%, which is not great for trying to dry litter out. And the birds can find it stuffy too. Whereas when in the shed with the sprinklers, the relative humidity in there was only about 65%, which is a lot better for drying the floor. This next figure here it's a series of thermal images which show what happened when the sprinklers turn on. So you'll see the water drop in a minute. And this is the shed that had the 3 lines of sprinklers, which is why you see the extra little bit of water go into the middle of the shed. And as the water evaporates off the birds, you see them start to warm up because that cooling effect finishes. But then at this time, 7 minutes later, the sprinklers run again. So some feedback that we got from the growers. They noticed that the fans and some of the other surfaces in the shed looked a bit dirtier because the dust was being attracted to the little bit of water that was put onto the surfaces every now and then. And that the feathers of the birds looked a little bit dirtier when they were getting picked up as well. Other feedback that we got was that the birds near the cool pad inlets looked a bit warmer during hot weather, but the birds were less stuffy at the tunnel fan end of the shed, presumably because of the lower humidity and the active cooling of the water actually going onto the birds up in that area. Both growers thought that it was a good backup cooling option, especially because it's relatively low cost at about $4,000 to $8,000 per shed and can be installed by the farm. And they also thought it would be good in very hot weather, and they found it to be good in very hot weather because it gets the birds to stand up and release the heat rather than workers having to go into the shed and try and walk through the shed and try and get the birds to stand. So just wrapping up, the greatest benefits that we saw were with water savings. So it might be suitable for farms with limited water, even if it's only a short-term limited supply, perhaps due to drought. It's probably good as a backup cooling option because of its low cost and the fact that it relies on low pressure, so you can use equipment that's already on the farm for it, and you get lower humidity in the shed, which can help with litter management. Some of the challenges that we found during the trial was coordinating the 2 systems, the control system for the sprinkler and the shed ventilation control system. But by the end of our trial, I think we had the settings pretty well sorted out. Choosing your alarm settings can be just a bit of something you need to think about because the sprinklers don't cool the air in the shed, so you need to be careful about what temperatures you set your alarms at. And just for installing the system, having ceiling baffles and other shed obstructions requires a little bit of thought about how to best install the system in the shed. If you'd like any more information about the trial or the sprinklers, please give me a call, or you can download the report from the AgriFutures website.